Let's do some compound interest word problems. So in question 4, Lee invests $800 into an account with an annual interest rate of 3.2%, compounded annually. For part A, we're going to calculate the final amount after 5 years, and for part B, we're going to determine how much interest was earned. So we're going to start off by identifying what we don't know and what we do know. So we don't know this final amount A. We are told that she invests $800, so that's P, her principal. Now for I, we are going to take our interest rate of 3.2%, divide it by 100, and then divide it by the number of times we're compounding per year. It's compounded annually, so this is just one time. And then N, total number of compounding periods, one time annually over 5 years. So we end up with N is equal to 1 times 5 and N is equal to 5. So let's write out our formula again so that we can memorize it. So we have A is equal to P times 1 plus I to the power of N. So P is 800, and then we have 1 plus 0.032. We don't need to put that divided by 1 there. And then the power N is 5. Now at this point you should be able to actually plug it all into your calculator. I'm going to do just one more step, or just write down one more step here. Oops. So 1 plus 0.032 is 1.032, and that to the power of 5. So remember, if your calculator does not do BEDMAS, you need to do the exponent first, and by that, I mean you have to do this part first on your calculator before multiplying by 800. If your calculator does do BEDMAS, then you can probably just put in all the numbers as is. So your answer here should be approximately $936.46. So remember, when we have money, we always want to round to 2 decimal places. Okay, so 2 decimal places for money. So this is the answer to part A. So let's just indicate that. Okay, so there's part A, there's our final amount. Now part B asks how much interest was earned. And we are going to use a variation on our final amount formula. So our final amount formula is A is equal to P plus I. In this case, though, we need to find I, and we have the other 2 components. So we can rearrange this. So we have interest is equal to final amount minus the principal. So our final amount is $936.46, and our principal is $800. So this means that our interest is $136.46. So that is our answer to part B. Next, let's take a look at question 5. So Andy invested $10,000 in a high interest account with an interest rate of 15.6% per year. If the money is in the account for 3 years, how much money will she have if the interest is? And we're going to look at A, B, C, and D. So compounded monthly, compounded weekly, compounded quarterly, and compounded daily. So I'm just going to write down the formula one time here to save space. A is equal to P times 1 plus I to the power of N. And we can still see it up above as well. So when we're compounding monthly, remember there are 12 months in 1 year. So A is going to be equal to $10,000, so the amount that was invested. And then we have 1 plus I. So I is going to be equal to 0.156, so 15.6% divided by 100. And that is divided by 12 because there's 12 compounding periods in 1 year. And then our exponent N is going to be 12 times 3. Okay, so 12 compounding periods per year times 3 years. So I am going to simplify this, and we're going to end up with 10,000 times 1.013. Now, this 0.13 comes from 0.156 divided by 12. And so that's an exact number there. That is not rounded at all. And then 12 times 3, that gives us 36. So here you should be able to put it all into your calculator, and you will get approximately, because we're going to round to 2 decimal places, $15,919.89. So we are going to do the same thing, compounding weekly, compounding quarterly, and compounding daily. So there's only 2 parts of the equation that are actually going to change because we're only changing the compounding periods. So right here where we see these 12s, those are going to change based on the compounding period. So if we look at part B, so weekly, there's 52 weeks in a year. Quarterly means 4 times a year, breaking the year up into 4 parts. And then daily, there are 365 days in a year. So those are going to be the key things that change. So I'm not going to repeat myself over and over again. And you should be calculating along with me to make sure you understand how to put all of this into your calculator. And I'm already making a mistake. Okay, that should be 52. Okay, so notice that the amounts are different between A and B when we're compounding monthly and compounding weekly. So you can see that compounding weekly, the final amount is slightly larger. So let's take a look and see if this trend continues. So now we're going to look at compounding quarterly. And we look at the final amount for compounding quarterly. We have $15,826.56. So we can see that we have a downward trend here on the final amount. So let's do compounding daily. Actually, sorry, I shouldn't say we have a downward trend. It depends on what order you look at them. We're going to talk about that in just a second. So daily, 365 days a year. So this one's going to be slightly more complicated than the others because we're going to have to round a number. But I really want you to try not round if possible. If you can put it all into your calculator in one go, that is the best, and that is the way to get the most accurate answer. So when we do 0.156 divided by 365, we get a decimal that is something like 0.00042, and so on. And I've lost space to put my exponent here, which is 1095 if we do 365 times 3. So notice I put ... because I am keeping all of those decimal places in my calculator. And it's actually pretty important to do that. We don't want to round to just 0.0004, because if we do that, then our answer is going to be quite a bit different than if we actually kept all those decimal places. So here our final answer is $15,966.38. So if we take a look at all of our final amounts and you look between A, B, C, and D, and let's actually take a look at the number of compounding periods in a year. So let's start at C. So C has 4 compounding periods in a year, and C also has the lowest final amount. Whereas if you go over to D, where we compounded daily, it has the most compounding periods in a year, and it has the greatest final amount. So what we can tell from this is that the more compounding periods you have in a year, the greater the amount of money is going to be, as long as you keep everything else the same. So I'm going to try and summarize that in a very short way. So greatest amount due to the most compounding periods if all else is the same. So if we don't change anything else.